Hello and welcome to the first video in a series of videos about problem solving in game development. This video will be on how I implemented a replay timeline system for Ascension. Now before we get started, we'll probably need to talk about what Ascension actually is and how we got here. In the summer of 2018, I felt that the game I was playing at the time, Osu, was starting to be too much of a grind, so I decided to quit the game. Eventually I decided to pick up Tetris again after not playing it for almost 6 years, and I ended up being okay at that too. One thing I really liked about Tetris was the creative aspect of it, being able to build these crazy structures that would end up resolving very nicely, so that was the aspect of the game I gravitated towards most. In March of 2019, I decided I wanted to start a big project combining all the aspects of Tetris adjacent games that I loved, adding in some new ideas of my own. This project would be dubbed Ascension, or ASC for short, although it's the same amount of syllables. And my goal with it wouldn't really be to compete with the most popular games at the time, but rather to try and do something new. ASC would introduce some new mechanics and leave out some other, less important mechanics. The main one here is that we're not just limited to the familiar 7 tetraminos, but any arrangement that could fit in a 5x5 square. Now this, of course, could lead to some extremely obtuse puzzles, but that's just the nature of the game. Fast forward a year and here we are. Ascension has 8 playable single-player modes, a map/puzzle mode, both with rankings, and a multiplayer free play mode. Now, to get to the real part of the video, ASC has a replayer system, meaning when you set a score, a replay of that score is saved to the database. Currently, the replay system we have is pretty basic. You can go forwards and backwards, pause and play, and speed up or slow down the replay. One thing that is missing, however, is a way to skip to an arbitrary point in the replay, sort of like a YouTube video. To do this, we're going to implement a replay timeline, which will be an interactive graph that shows the average pieces per second over time, so that the user can select where on the graph they want to skip to. Okay. So, to get to the technical parts, ASC is written in TypeScript, which is a typed version of JavaScript. That basically means all the variables have types, so like a number or a string, etc., etc. So the first thing we need to do is figure out how we actually want to get the charts to appear. So I could draw the entire timeline myself using the HTML canvas, but that would be a lot of extra work for no reason. So let's see if we can find a library that will do the job. Of course, the first thing that pops up into Google seems okay, but I also need to check that it has TypeScript definitions, otherwise it'll be a huge pain in the ass to work with in my project. Thankfully, it's a pretty big library, so we're good. Choosing a library is a pretty big decision because we still need to make sure it can actually do what we want it to do. Obviously, it can draw a graph, but we need to make sure it can do the interactive part easily. It looks like chart.js takes in a canvas itself, so worst case scenario, we'll just add in event handlers to the canvas and it should be fine. Okay, so let's set up a function to do the drawing. First we'll have to figure out how chart.js actually works, and it seems like it's pretty simple. You just make a new chart, you give it some options and data, and it should work. So let's get some data. So first we'll just calculate the time between hard drops, and then we'll graph that over total time, which is pretty simple to do with just a for loop. And currently that's seconds per piece, but we want to switch it to pieces per second. But just for now, we'll do that. Let's also add a canvas to the replayer page so that we can actually test it and see if it works. Okay, so it looks like it's black on black, so let's fix that. We'll just make it red for now. Okay, well, it looks like something else is wrong because there should be more than 2 points on the graph. There should be a bunch of stuff. So after just Googling and banging my head against a wall trying to figure out what's wrong, it looks like this is a pretty common problem, and it's just due to the line chart being configured incorrectly. So now it looks fine, but the graph is kind of messy. So to reduce the clutter on the graph, let's take an average of the last X pieces. For now, we'll just use 5, but that can be changed pretty easily. So all we have to do is just, instead of adding a new point every hard drop, we just need to add a new point every 5 hard drops and take the average. Okay, that looks better, and the chart's less all over the place. Okay, so the next thing we need to do is the current time marker. People were saying to use the chart.js annotation plugin, so I thought I'd give that a try. It doesn't have TypeScript types, which isn't a good sign, and I quickly realized that it's not updated, and it doesn't even work with the newest version of chart.js. So we're just going to draw the line ourselves. Thankfully, on Stack Overflow, someone posted a way to do it using a chart.js plugin, so I just modified what they had and stripped it down into basically what I needed. The chart.js documentation is very lacking for the plugins. It doesn't really tell you how to do anything, or it just says like, here's the name of some functions you can call, and it doesn't say what they do, or how to use them, or what parameters they take. So it's kind of just like a mess. After doing some math to scale the line properly and put it in the correct location relative to the actual graph itself, not the canvas, looks like it works properly. So that's good. And then now we just need to tweak some things and add a callback to update the chart in the replayer so the line actually updates. Okay, and now we need to add a click handler to the canvas itself, and then do some math to calculate at which point they clicked on the graph, rather than just like where on the canvas they clicked. And then we can just make a function to skip to any point in the replayer, and it's done. So overall, things went pretty smoothly, other than a couple of hiccups here or there, like with the choosing the chart.js annotation plugin when it doesn't really work. Things worked pretty well. At certain points, I had to just, go in and actually just print out the entire object to try and figure out what I should be messing with, because the documentation doesn't really tell you how to do anything. But other than that, it wasn't too bad. There's lots of resources online and people trying to do the same things as me, so it makes it pretty simple for that. Overall, I had a lot of fun making this video. I think it's good for people who don't program to sort of see what stuff goes into actually coding and implementing stuff. And it's also good for people who do program to sort of see how you do it yourself. The video is a little weird to make because I sort of just recorded everything and then tried to write a script afterwards, where it would probably be better if I sort of came up with the script as I recorded. But yeah, that's just the way it turned out. So hopefully it's not too awkward to listen to. I think I'll do more videos in the future, but definitely forming a script as I go instead of just having like 6 hours of coding footage and nothing to go off of, because scrubbing through all that is a pain. And yeah, thanks for watching.